So can you hear me clearly?
Yes, sir.
Yes, sir, we can hear.
Yes. Thank you, Sanuka. So only for this week, we have to conduct our lectures in Flashbook through Zoom, right? So today I'm going to have a short lecture on to complete our remaining part on tire part, right? Tire section, and today I'm going to start the next chapter, brake system in automotives, right? So let me share the screen first. Right? Yes, hope you all can see my screen. Is it Sanuka? Can you see my screen?
Yes, sir.
Okay, so up to now, actually, last time we started the topic automotive tires, right? So up to now, we have got some sort of idea about the tire construction and the classification, the types of available tires, right? So we wind up the session at here, right? So our next point is run flat tires, right? So in the case of modern automotives, run flat tires are imagined, right? So this is the kind of new technology which in Sri Lankan context, I think BMW 5 Series and 7 Series are equipped with run flat tires. So that is the only model that I know which are available, which are fitted with run flat tires, right? So if you know any further or any additional automotive type, please mention in the comment section, yeah, the chat section. Right, earlier we had only tube tires. Then yes, we have solid tires, and most common tire type is tubeless tires, right? So the issue in tube and tubeless tires is once you experience a tire puncture, so the pressure with the air will be de-inflate, and there is no possibility to move with the damaged tire, right? Basically the tire with the puncture, right? So the run flat tires, basically run flat tires can drive some amount of distance even with the de-inflated tires, right? So that is the important factor here. As you can see in the figures, right? As you can see in the figures, in the cross section, we have a additional structural member inside the tire, which is attached to the rim section, which can give us the support. Even we don't have any pressure inside the tire, right? And also that is the auxiliary supporting system, and also the tire is having a self-supporting mechanism where our side wall is having additional reinforcement while maintaining the required flexibility, right? So the side wall can provide both flexibility and the strength required. So this is much useful whenever the inflation pressure is lost during any kind of tire puncture, right? So bead design should be appropriate here, because you know that even in tubeless tires, the tire will be attached to the rim with the air pressure, right? So bead will be in contact with the rim section due to the air pressure inside the tire. But once you experience the tire puncture, so there will not be any air pressure inside the tire, so that your bead design should be sufficient enough to maintain the contact in between these two, even after the pressure loss, right? So that is the thing that I need to especially mention here about the bead design, wire bead. And side wall is having additional reinforcement, right? And flexible and low hysteresis rubber, which means that it cannot actually the failure failure of the side wall due to the hysteresis effect, or let's say due to the flexibility effect is lower here. And material is thermal resistive, and the material will be a metallic coat textile. Metallic coat textile tissues will be there as the reinforcement just to enhance the flexibility and also the strength, right? And so here we have the similar to the our um normal tire patterns. We have thread at the crown, so it can it can achieve the required traction and the friction with the inflated tires, right? So it can normally operate as a standard tire, but it can give some sort of additional range whenever the pressure loss is there, right? Something like a tire puncture, right? So suppose you can drive with the inflated tire. Let's say it is the range maybe 2,200 kilometers per hour with these run flat tires. Let's say, just assume. So once you experience a tire puncture, so then you can drive around 50 to 70, 60 kilometers per hour. So that speed is manageable with run flat tires. So the range is normally, they say, the range is normally lying between 40 to 50 kilometers, right? So then you can reach to a service station, tire service station, and you can replace or repair the tire, right? So that is the procedure. So what is the advantage of these run flat tires? The first one is that we can drive the vehicle even though we have a pressure loss inside the tire. So that is the primary advantage. And also there are several secondary advantages as well. So what are they? So the second main point is that we don't need to have any spare wheels, right? So we don't need to carry a spare wheel or spare tire, so that we can increase the boots or luggage space, right? We can increase the luggage space, and also the weight. So this particular tire or combined wheel is that's a weight saving. It may be around 20 kilograms, let's say 20 kilograms, 50 to 20 kilograms. So ultimately, due to the reduced weight of the total automotive, so there will be a fuel saving, right? So there are several other advantages also, but these three are the main advantages of using run flat tires, right? Those are the things that I need to mention here about the run flat tires. So, and when it comes to tread designs, in the standard tires, we have four main tread patterns here. The first one is directional, right? So here you can see the threads are manufactured or designed in a directional manner, right? So that we can say it revolves in a particular direction. Here you can clearly see the direction. So this direction is important here because it can drain out the water and mud effectively whenever we drive the vehicle in a wet condition, right? So as I told you earlier, the main reason of having a particular tread pattern is to improve the traction in wet conditions by wiping out the water and mud which comes in between the tire and the road surface, so that if our thread pattern is having some sort of directive design, so it can effectively wipe out the water, right? So just to reduce the aquaplaning situations, right? Directional thread patterns are used with all season tires to more effectively channel water from under the tire and improve wet tractions. So this is not much applicable in Sri Lankan situations, but you know that in some countries there are some seasons, right? There are some seasons the road is dry, but there will be some time period where the roads will be wet due to the snow and basically due to the ice, right? So that the tires should be designed to accommodate both seasons, or the owners or drivers need to replace their tires based on the season, right? If they are driving in a dry season, they need to install a different tire set. Whenever they driving in a snow condition, they need to replace tires with dedicated uh, tires for snow conditions, right? But these directional tires, we consider these directional tires are as all season tires, right? So it can improve the traction in both in dry conditions and wet conditions, right? And then non-directional threads are here. So compared to directional one, we can't see any directive way or direction here, right? So it can perform equally well regardless of tire's rotational direction. Here we have in directional thread, there is a uh, recommended rotation direction, so that direction can be easily uh, checked, because the rotation direction is mentioned in the side. I will show you later using a figure, right? That the rotational direction is mentioned in the tire, right? So once we apply in a wrong direction, let's say the tire is recommended to rotate in clockwise, and we have attached to the counterclockwise direction. So normally direction can be taken as the forward direction, right? So once the vehicle is moving forward, we can take the rotation direction. But suppose we have intentionally or unintentionally swapped the tires where the rotational direction is not matching with the manufacturer's standard. So then we can experience more vibrations and jerking, because the tread pattern is designed based on the rotational direction. Especially, it will lose the traction once we have some sort of wet condition. So if there are wet conditions, then the traction will be drastically reduced, right? So that we need to ensure that our rotation direction of the tires are correct, right? And so normally, as you can see, this is a truck or trailer tire. So where we can't expect much more traction and the performance, right? The friction and the uh, performance are comparatively lower in non-directional threads, where it is normally, normally it is designed to carry the loads, right? Something like heavy trucks and trailers, right? And we can see some symmetric threads where we have symmetrical thread patterns in both side, left and right side, and also we have asymmetric thread patterns, right? So in Sri Lankan context, in most of the passenger vehicles are equipped with tires where we have symmetric threads. So the traction conditions are similar, and the friction is similar in both sides. But in asymmetric threads, we have different traction levels, right? So why this is designed as having two thread patterns in both sides? So so one side is designed to improve the traction while we drive in a straight way, right? And the other side is designed to improve the traction once we take turns, right? So as you can see, the left side of this tire is designed to uh, have some more traction while we drive in straightways, right? So based on that, the tire should be correctly installed, right? Otherwise, there will be issues, right? So normally, the inside half should be sufficient enough to supply the traction required for forward moving, right? While the outer side should be designed to improve the traction while take corners or turns, right? So that I will explain you why inside force right and outside for cornering later during wheel alignment section. But anyhow, there are two tread patterns in inside and outside. Inside for straight line and outside for corner, right? So that's all regarding prior tread patterns. So any question up to now regarding run flats and thread patterns? Right. Then tire ratings. So as I said earlier, the tire sidewall is basically supports the tire and the cushioning properties will be given. And also the tire information, all the tire informations are mentioned in the tire sidewall, right? So normally in the sidewall, we can see some sort of information. Actually, the first one is that the tire brand and the ply orientation and recommended rim size and the tire width, spec ratio, and the diameter, and the inflation pressure, maximum inflation pressure, and the maximum load. And so the recommended vehicle type, whether it's passenger car or heavy duty or off road, right? And the ply orientation, whether it's radial or any bias type ply orientation, right? So all the information are mentioned. And also the manufacturing date and the week of the manufacture is also mentioned. Right. So when it comes to tire size, so this is quite important, right? Normally, in a tire, we can see this type of notation, which is important to grab some knowledge about the tire size, right? So, so I have taken this particular section to here to discuss, right? So here you can see that it is P215 slash 65 or R15 and 89H. So each of these letter and the symbol is having a meaning, right? The first one, P. P is for passenger car, right? If it is LT, then it means that it is the tire is recommended for light truck. And ST, if it is ST, then it is called special trail, right? And if it is T, which means temporary, right? So temporary means, have you seen some spare wheels? We call it solid tires. So in solid tires, we can see the letter T. So T means, oh, it is only for temporary use, right? So these are space saver spare wheels. Right, so that is the idea regarding this first English letter. And then we have 215. 215 means section width, right? Section width in millimeters, right? In this tire, the width of the tire. So what do you mean by width of the tire? Yes, this width from here to here. This width is 215 millimeters, right? Millimeters from side wall to side wall. එක පැත්තක wall එකේ ඉඳලා අනිත් පැත්තක wall එකට යන්න. Right, then that is the idea of these three letters. 215, we have 195, 185, 175, 165, 155, and also we have some higher values, 202, 25, 245, right? So whenever the value is increasing, the tire width is increasing, right? value එක වැඩි වෙද්දී tire එක වැඩි වෙනවා. So that is clear. And slash 65. So 65 means aspect ratio, right? Aspect ratio means actually it is the notation which we can use to calculate the tire height, right? So yes, so this is the meaning of aspect ratio. So section height divided by section width, right? So in here, the proportion or the percentage of the section height is 70% because we have the height as 7 inches and width is 10 inches. Then the percentage or the aspect ratio is 7 divided by 10. So that in here, the number should be 70. So what happens if number is 65? Your section height is 0.65 times section B. මේතන කොහොමද එතකොට සෙක්ෂන් විත් එක 215යි ඒ වගේ 165 තියෙනවා සෙක්ෂන් හයිට් එක. right 215.6න් පහෙන් ගුණ කරාම ඔයාලට එනවා මෙන්න මේ උස. right so that is the meaning of the aspect ratio. So if the aspect ratio is high, so we have tires with 85 aspect ratios, as I know, which means the section height is pretty much higher compared to the width, right? So the tire height is higher. We call it balloon tires, right? Balloon tires can provide some sort of higher comfortability because sidewall width is high. 65 කියන එක aspect ratio වැඩි කියන side wall එක ගොඩක් උසයි. tire එක උසයි. Suspension හොඳයි, cushioning හොඳයි. So if we need higher comfortability in our vehicle, so the tires with higher aspect ratios are recommended, right? So and also we have low profile tires other than the balloon tires. If the aspect ratio is lower, let's say it is 55, right? So let's say it is 45, right? So which means it is 0.45 times of width, which is having very low height in the tire, right? So we call it low profile tires, where it cannot provide higher comfortability, but the performance wise, the tires are recommended, right? So that is the those are the things that I need to mention here regarding the aspect ratio. And then you can see the fourth terminology here, R, right? So R is basically referred for radial, right? So that is our ply construction. You know that we have main three ply orientations. The first one is radial orientation, radial construction, and then belted bias and bias. We have discussed these construction types during our previous session. So if it is R, we call it radial tires. If it is B, then belted bias, and if it is D, bias fly orientation, right? So that is regarding the fourth terminology term. And then you can see another numerical value. Here it is 15. 15 is the rim diameter in inches, right? Rim diameter in inches. Here we have the rim with 15 inches of diameter, right? So, and we have 12, 13, 14, 16, 17, right? Because we have, we can purchase tires with different diameters, different inches, right? The thing that you need to keep in your memory is this 250 is for tire width in millimeters, 65 is the aspect ratio. It is a percentage value, 65% here, and R is for radial, 15 is the rim diameter in inches, right? inches millimeter percentage ඔය තුනම තියෙනවා ඔය nomenclature එක ඇතුළේ. Is it clear? So then the last term, 89H, right? So here, this is the loading index. 89 is the load index, H is the speed rating. Here, let's see what is 89. So this is the loading, maximum loading that a tire can withstand. It is 580 kilograms per one tire. And H is the speed rating. So then this tire can drive uh, up to 210 kilometers per hour speed, right? So whenever you buy a tire, for your vehicle, so both geometrical considerations and loading and speed considerations should be checked, right? So in Sri Lankan countries, we know that even the speed rating Q is sufficient because we don't have any roads to drive up to 160. But uh, these things should be considered, right? අපි මේ loading index එක ඊට අමතරව speed rating නොබැලුවට මෙතන ලොකු ප්‍රශ්නයක් වෙන්නේ නැහැ. Especially speed rating එක මොකද 160ට යන්න පුළුවන් පාරක් සෝ recommend කරන්න පුළුවන් පාරක් නැති නිසා නමුත් හරියට බලන්න නම් මේ සේරම බලන්න ඕන. Right? Yes, those are the things. Here we have several examples. You can compare the tire sizes and tire widths, right, based on the given codes. Yes. So one thing that I need to mention here, the thing is that we can swap the tires actually, right? So since this is much common, pretty much common in Sri Lankan context, and also some vehicle owners do this, right? So my point is, so there are situations where we can obtain same peripheral length even with different diameters and section width and aspect ratios, right? So normally in the common standard, that the vehicle manufacturer recommends a tire profile and the rim sizes for a particular vehicle, right? So those informations are mentioned in the body area of the vehicle. So normally it is at the door area, right? Simply just behind the door hinges or whatever, right? Near the door areas, right? So normally the manufacturer mentioned the tire size, especially this cone, right? And the inflation pressure as well, right? So suppose you need to change your tires and the rim just to improve the ground clearance or just to lower the ground clearance, right? So both things happen, right? So, but it is not recommended to change the tire sizes, rim sizes, because it is mainly affecting on the vehicle stability and especially fuel consumption and also the torque variations. Right? So maximum torque will be changed, right? And the thing that I need to mention here is, so there will not be much effect if you can change the tire while keeping this peripheral length, right? Keeping this peripheral length as a constant, right? Suppose, so let me give you an example, right? So suppose you have original factory fitted 15 inches wheels with a higher aspect ratio, right? Suppose you need to swap this wheel with 16 inches tire or rim, right? Then what you can do is, so you can refit the 16 inches rims to the wheel, to the vehicle, while lowering this aspect ratio. So then what happens? මේක වැඩි කරනවා aspect ratio එක අඩු වෙනවා. නැත්නම් rim එක ලොකුයි, tire height එක අඩුයි. low profile tires වලට swap කරන්න පුළුවන්. නමුත් ආයි බලන්න ඕන මෙන්න මේ section width එකෙන් 65ක් නේද? ඒතකොට section width එක constant තියන්න ඕන. ඕව අඩු කරලා ඒ විදිහට ගාන හදලා ගන්න. Right? So my point is, while maintaining this peripheral length, you can swap the wheels, right? You can change the rim sizes and tire sizes. So what happens if you don't match these aspect ratio and the rim sizes and also the peripheral length? What happens? So there will be major issues. First one is that the stability will be reduced, and the other thing is that your meter reading, speedometer reading, or odometer reading will be incorrect, right? Because there will be a error in the peripheral length, because peripheral length is directly proportional to the speedometer reading, right? Those things will be there. So actually I included one small calculation type, mathematical calculation for your previous year batch, just to calculate the speedometer error once you replace the tires with the different tire size. Right? So it is a simple case, right? So normally you can get the tire width and the diameter using this code. Then you can simply use C equals 5 equation to calculate the peripheral length, right? So then you can easily calculate the error with the original tire, right? So that will be direct into the speedometer change, right? So if you need, you can just apply some values here, and then another values for the similar values for this code, then you can get the error, right? So I'll give you one example as a take-home assignment, right? Just to know the method, right? So then inflation pressure. So inflation pressure is pretty much crucial in automotive engineering, because a proper inflation pressure will maintain the tires quality, and it will ultimately it will enhance the tire lifetime, right? So and also the comfort, riding comfort, the suspension system will be working properly with the correct inflation pressure, and the stability will be increased, and ultimately fuel economy will be increased, which means that uh, the pressure should be in the correct range, where it should not be lower or higher, right? So that a too little air pressure can result in tire squealing, and steering will be difficult, right? There will be some noises, and if the pressure is higher or uh, lower than the recommended value, and then the heat generation, the temperature of the tire will be increased, and especially the tire wear pattern will be abnormal, right? And also the fuel consumption will be lower, right? So that is why we need to maintain the correct pressure. So suppose we have only three cases. So the first one is correct tire pressure. So then everything will be okay, right? And the other thing is that over pressurized tires and tires with lack of air pressure, right? So those are the three cases. So suppose you have a tire with overinflation, higher air pressure inside the tire. So then what happens? So the contact area of the tire with the road will be reduced, right? So the top of the crown will be in contact with the road surface, so that there will be higher wear in the top of the crown, right? So this is the contact patch area, which is denoted in the figure here, right? So in this area, the tire wear will be higher compared to the outer areas, right? So suppose the other case, think about the other case, the underinflation, so that the tire crown shoulder section will be in contact during normal riding, right? So that the tire wear pattern will be something like this, right? So there will be more wear at the shoulder areas compared to the top of the crown, right? So those are the cases, and there are some special cases like crack threads, right? As you can see here, we can see some cracks in the tire. Doesn't matter the inflation pressure is higher or lower, or excessive speed or lower speed, there will be some cracks, right? So these cracks happens mainly due to the the uh, lifetime of the tire, right? That if the tire is having lower lifetime, then there will be some cracks, and especially if the tire manufacturing date is too early, right? Then there will be cracks like this. The worst case of having cracks is, so once you drive with some sort of cruising speeds or highway speeds, there is a possibility to having some sudden failures in tires, especially the crown area, thread area will be wiped out, right? So those shoulders and the crown area will be damaged suddenly. So it will be finally it will be some sort of catastrophic failure. So that you should be aware about the tires manufacturing date. So in normal situations, in standard situations, tires are only recommended for 5 years, right? If your tires are older than 5 years, which means even though you have a good tread pattern still, but your tires expired, right? If the manufacturing date is, let's say this is 2025, so this is 2025. If your tire manufacturing date is earlier than 2020, which means your tire is expired, right? So maximum time is 5 years. So how to find the manufacturing date or year in your tire? How to find? Actually, the in the sidewall we can easily see the manufacturing date. So in here it is not mentioned. Actually, so let's say it is manufactured in 2024. Then we can see a notation something like this: 2, 4, and some another values. Let's say it is 10. Right? So let's say we have a 4 digit number which is mentioned at the side wall, like 1024, which means that 24 is the manufactured year, right? 2024. 10 is the week of the manufacture. So අපි කියන්නේ ඒ 2024 අවුරුද්ද මොන සතියේද? මේ 10 වෙනි සතියේ තමයි manufacture කළා තියෙන්නේ. Is it clear? So someone can calculate which week is this, right? So let's say it is 50 වෙනි සතිය නම් 50යි 2025. Right? So then we can easily see the remaining lifetime of the tire, right? So it is recommended to replace the tire after 5 years, even though we have a good tread pattern. Otherwise, there will be some cracks like this, and there will be catastrophic failure. Right, then tire pressure monitoring systems are much more common in modern automotives, right? There is a pressure sensor attached to the inflating valve, right? So that once the pressure is low, actually all four pressure values can be read in the vehicle's dashboard. If there is any leaks or lower pressure in wheels, then we can easily warn, right? So the tire pressure monitoring system will be pop up some lights to warn the driver that there will be air leakages in tires, right? There is a built-in battery that is not replaceable. The whole unit is replaceable. So once the system is weak, then you need to replace the whole valve and the transmission system. So this is a wireless transmission, radio transmission system is there. So that you need to replace the whole system, not the rim. I mean the valve and the transmitter, valve, sensor, and the transmitter. Right, there's the indicator light in the dashboard that driver can easily see the warnings. Uh, Anything regarding the tire pressure loss. So then the next part, the tire or wheel balancing, right? So basically, the wheel balancing is crucial just to make sure that our wheels are not vibrating, right? So there are two patterns of vibrating due to two types of imbalancing actually, right? So the first one is static and second one is dynamic, right? Hope you all are familiar with static balancing and dynamic balancing, which was conducted. The lecture was conducted under your year 1 semester 2 applied mechanics, right? So this is rotor balance, right? The same thing happens there. So what happens if there is any sort of static or dynamic imbalance? So there will be some sort of increased wear in some spots in the wheel, right? සමහර spots වල විතරයි wear එක වැඩි. Suppose you have a tire with heavy weight, right? Let's say you have a tire weight attached to here. අපි හිතමු මෙතන weight එකක් තියෙනවා කියලා. Right? So let's say it is 100 grams. 100 grams. So what happens when it rotates? So all other, so without this 100 gram, let's assume that our tire is fully balanced, right? So once we apply this, once we attach this 100 gram weight to the tire, so what happens while it rotates? There will be a excessive centrifugal force. මේක attach කරාම මේක නිසා එන centrifugal force එකක් එනවා. මේක නැත්තම් ඒක නැහැ. Right? So which means our system is not balanced, right? So there will be a resultant centrifugal force. Due to this centrifugal force, there will be higher wear in this area, right? මේ ඒරියා එකට අමතර බලයක්. මේ centrifugal force එක නිසා වැඩියෙන් බලයක් එනවා අනිත් ඒවාට සාපේක්ෂව කැරකේ. ඒ නිසා මේ ටික වැඩියෙන් ගෙවනවා, right? So if you have this type of mass, let's say it is an inbuilt mass due to an imbalance in tire or rim area, rim section. So what we can do is we can't remove these 100 grams. What we can do is we can attach another 100 gram to this side. ඔහොම තමයි balance එක. මේ ටික අයින් කරන්න දෙයක් නැහැ. ඒ වෙනුවට කරන්නේ ඒක compensate වෙන්න මේ අනිත් පැත්තට weight එකක් add කරනවා. So if we don't consider about the symmetricity, if we are just applying the 100 gram to the opposite direction, then we can experience no resultant force actually, right? So then anyhow the system is balanced, we call it static balance. ඒ වගේම weight එකක් අනිත් පැත්තට දැම්මොත් අපි ඒකට කියනවා statically balance. නමුත් ඒක කැරකෙද්දි ආයෙ යනවා vibrate වෙන ගන්න. ඒ කියන්නේ නිශ්චල අවස්ථාවේදී balance මොකද weight එක balance කරලා තියෙන්නේ. Right? So if our wheel is not statically balanced, we can experience some sort of vertical oscillations. Right? If our wheel is not balanced statically, we can experience up and down motions once we drive in some sort of moderate speeds. Let's say 40 kilometers per hour. 40ට විතර යද්දී එක එක වේගවලින් තමයි එන්නේ. 40ට විතර යද්දී උඩ පහළ යනවා දැනෙනවා. සස්පෙන්ෂන් උඩ පහළ වාහනේ ගැස්සෙනවා දැනෙනවා. So this might be a reason, right? This might be a reason due to static and dynamic imbalance issue, right? So wheel goes up and down due to the centrifugal force. Right? Suppose you have so let's say the imbalance happens due to this mass, and you can attach another mass to this side, the opposite side, to statically balance the system. Statically imbalance එකක් තිබ්බ. ඒක නැති කරන්න ඒ වගේම තව එකක් අනිත් පැත්තට දැම්මා. Right? So now still the system is imbalance due to the dynamic balancing effect, right? So how to in here in static balance is the equal distribution of weight around the wheel, right? Doesn't matter what is the location. මෙන්න මේ axis එක වටේ උඩ තියෙන weights ටික සමාන වෙන්න ඕනේ යට තියෙන weights ටික. Right? So that is the static balance. But it is done by adding compensating weight. So these are the conditions for having a statically balanced system. All the forces should be zero, equals to zero. All the moments around the rotating point should be equals to zero, right? So that is the statically balanced, but the system is still dynamically imbalanced. To dynamically balance the system, so we need to balance the system. All the weights around this axis should be equals to zero. මේ center line එක එහෙම නැත්නම් අපි ගන්න symmetric axis එක දෙපැත්තේ තියෙනවත් සමාන වෙන්න ඕන. ඒ කියන්නේ මේ axis එක වටේත් සමාන වෙන්න ඕන. මේ axis එක වටේත් සමාන වෙන්න. එතකොට මෙහෙන් weight එක දානවා නම් මේ පැත්තෙන් තමයි අනිත් එක දාන්නේ. වැඩියෙන් වෙලා ඇවිල්ලා තියෙන මෙහෙන් නම් අනිත් එක මේ පැත්තෙන් එන්න ඕන. Otherwise if we attach the weight on this side, the system will be statically balanced, but not dynamically, right? So then there will not be any centrifugal force or couple produced during the rotation, right? So suppose our system is statically balanced but not dynamically, then your wheel will be tend to vibrate in horizontal way. අරක උඩ පහළ ගියේ දැන් වීල් එක දෙපැත්තක තමයි අපි කියන්නේ වීල් එක බෑරින් ඉෂුව එකක් නැහැ කියලා හිතෙනවා. ඒත් නැත්තම් දෙපැත්තට අපි කියන්නේ බකල් වෙලා කැරකෙනවා කියලා. එහෙම වෙන්න පුළුවන්. මෙකැනිකල් කිසිම ප්‍රශ්නයක් නැහැ. නමුත් දෙපැත්තට එනවනම් ගොඩක් දුරට dynamically imbalanced tire එකක් වෙන්න පුළුවන්. Right? So actually the driver can feel the vibrations while running at 40 to 50 kilometers per hour speeds, right? So then what you need to do is you need to balance the wheels, all four wheels, using a industrial level wheel balancer. So then the technician will attach some compensating weights based on the direction. So you all have a practical for this wheel balancing with the available wheel balancing machine. So you can experience, right, during the operation. Yes, so this is how we can attach the weights. For inner side, we can apply these weights using the inbuilt adhesive methods. For the outer sides, we can attach some mechanical compensating weights, tangible and compensating weights, which are directly attached to in between tire and the rim section, right? So others, for the inside, we can glue it to the inner wall of the rim, right? And one additional thing I believe that it's better to mention here, and also, so this is a one method. Static and dynamically imbalance is a one method of having vibrations in the tire. The other one is if your tire is almost at the end of the lifetime, then there will be a issue. There might be some issues with with your plies, right? Metallic plies, right? So with the time, there is a possibility to have some cracked plies, right? Cracked plies. So then what happens? The tire profile may be changed at some points, right? So there may be some air bubbles, right? There may be some air bubbles, so that your tire will not be complete cylindrical shape. There will be some air bubbles in the surface. Then what happens? Once you drive with these air bubbles, there will be some vibrations, right? So what you need to do is you need to be careful about the tire's manufacturing date. Then most of the issues which comes on the tire lifetime will be reduced. ඔය වගේ කාලයක් පදිද්දී ඔය වගේ එයා බබල්ස් එනවා කම්බිය ප්ලයිස් කැඩිලා ඒ වගේ වෙන්න පුළුවන්. එතකොටත් vibration එනවා. The interesting thing is that you can't feel these vibrations due to damaged plies or metal cords. You can't feel these vibrations at lower speeds or very high speeds. Again, you can feel under moderate speeds. 40ට 30ට 50ට වගේ යද්දි විතර වයිබ්‍රේට් වෙලා ඊට හායි වයිබ්‍රේට් වෙන්නේ නැත්නම් මේ වගේ එයා බබල්ස් ඇවිල්ලා වෙන්න පුළුවන්. right? අඩු ස්පීඩ් වලදී දැනෙන්නේ නැහැ, වැඩි ස්පීඩ් වලදී දැනෙන්නේ නැහැ. Right? Those are the things which I need to mention. And finally, wheel alignment, right? Wheel alignment is most crucial one based on when we consider about the lifetime of the tires. Um, in here, you can see that two different cases. Here, in the first one, toe angle, and here you can see in the first image, toe in, or we call it positive toe angle, right? So where our front tires, both the steering tires, are heading towards the center, right? So here you can see that angle. So both wheels are not parallel. So these tires are heading towards some sort of center, which is located at the outer area, right? So center is here. Let's say center is here. But in toe out case, here you can see both tires are directed in outward, right? So we call it negative toe angle, right? So, so what do you think about these angles? So which one is better? Or do we need to have some parallel wheels? So let's say what happens if we have these wheels at an angle while moving forward. The tire wear will be increased නේද? So අපි මෙහෙම ඉස්සරහට යද්දිත් මේ වගේ angle එකක් තිබ්බොත් මොකද වෙන්නේ? Tire wear will be increased so that you can see some excessive wear in some sides of the tires. එක්කෝ පිටපැත්ත ගෙවනවා එක්කෝ ඇක්කුල් පැත්ත ගෙවනවා. Right? So it will drastically reduce the lifetime of the tire. Actually, the tread depth will be reduced, right? Tread depth will be reduced. There are some indicators in the tire. Can we see some indicator? So actually, sorry, I forgot to include a tread wear indicator photo. Right. Normally, tread wear indicators are located in tires. Let's say අපේ ටයර් එකේ මෙන්න මේ වගේ එක තැනක මේ වගේ රිබ් එකක් තියෙනවා. දැන් එක තැනක නෙවෙයි තැන් කිහිපයක්. So these are the tire wear indicators. Once your tread height is can you hear me? Yes, Sanuka, can you hear me?
Yes, sir.
Yes. Sorry, just give me 1 minute. My laptop was disconnected from the Wi-Fi. Right. Sorry for the interruption. There's a power cut. Anyway, so we can continue the session, right? So I was explaining about the tire wear indicators, right? In here, so somewhere like this, we have tire wear indicator, something like a rim, which is having a lower thread height, right here. So once our tire is fully worn, right? Once our tire is fully worn, this thread pattern will be uh, uh, linear, or it will be level up with the tire wear indicator, right? So once we reach to this level, we need to replace the tire actually, but it is not much common in Sri Lankan context. We drive with the same tire just once until we see no thread pattern there, right? So that is not recommended. Actually, once we see the tire wear indicator, which is leveling up with the available thread pattern, thread height, so the tire should be replaced with a newer one, right? Um, yes, then what else that we can discuss here? Yes, toe angle. So both positive and negative might be useful in some scenarios, right? Actually, so in let's say we have a rear wheel drive vehicle, right? Then the recommended toe angle is toe in, right? So and if we have a vehicle with front wheel drive, then there should be a negative toe angle for front wheels, right? So why positive for rear wheel and negative for front wheels? So I'm referring to front wheel drive and rear wheel drive, not just front wheels and rear wheels. So let's take examples. Suppose our engine is powering our rear wheels here through a propeller shaft, right? Here, this is our differential. So then what happens? Our rear wheels are pushing the vehicle to this side, right? So then what happens to our steering wheels? The steering wheels mean front wheels. අපි steering wheel එකෙන් කරකවන wheel එක නෙමෙයි අපේ front wheel එක. So then what happens to the front wheels? So these front wheels will tend to bend in this direction, right? Then finally, while we drive the vehicle, front wheels will be in parallel, right? There will not be any toe angle. The toe angle will be zero. So let's assume it's zero, but it depends on the vehicle speeds and the given torque. But anyway, if our vehicle is rear wheel drive vehicle, so the toe angle should be positive. So once we start the driving, so the toe angle will be reduced. It will be almost zero, right? So that is why positive toe angles are recommended for rear wheel drive vehicles, right? So this is මේ පේනවා වගේ ලොකු ඇංගල් එක නෙමෙයි අංශක 3ක 2ක 3ක වගේ ඇංගල් එක. මේක පේන්න ඕන නිසා තමයි ලොකුට දාලා දෙන්නේ. So if you have a front wheel driving vehicle, so our engine is powering these front two wheels, then what happens? So these wheels are rotating, right? These wheels are rotating. So wheels are trying to bring this vehicle and the chassis, right? Then what happens? This wheel is trying to twist in inner side. Right? මේක නිකන් ප්‍රැක්ටිකලි හිතන්න මේක කැරකෙද්දි කොහෙටද ට්විස්ට් වෙන්න හදන්නේ? ඇතුල් පැත්තට. Right? So these are trying to twist the inner side or the front towards each side. While driving, these wheels will be in parallel, right? So that is why the negative toe angle is recommended for front wheel drive vehicles. So is it clear? මේක දැන් rear wheel එකකට මේ වගේ එකක් දුන්න මොකද වෙන්නේ? මෙහෙම push කරද්දි තවත් මේක මේ දෙපැත්තට යනවා දකුණු පැත්තට. ඒ කියන්නේ එළිය පැත්තට එනවා. ඒකට negative toe angle එක තවත් වැඩි වෙනවා. ඒක recommend කරන්න බෑ. So and also camber. Camber is the angle in between vertical direction and the tire's axis, right? So camber is also depends, right? So camber is also depends. So based on the driving condition, but normally we prefer negative camber in on-road driving. So where it can support the traction, especially in while taking corners, right? Especially while taking corners where the camber will be, the negative camber will support some sort of increased traction, right? So there are some sort of situations where we recommends some negative cambers as well and positive cambers as well. But ultimately, there should be a proper angle from toe and camber, and also the cast angle should be in proper manner, just to reduce the tire wear and especially to increase the traction, right? So those are the things. And here you can see that the touching area or the touching section of the area is reduced here. So, and also reduced here, right? Everything should be in a proper manner. That's all regarding tire section. And one thing I need to mention further here, actually, I was unable to include that particular slide there. Suppose you are driving in sand condition, suppose this desert, right, where it's not an on-road condition. Suppose we have some sort of sand, something like a beach, right? So what happens if you drive with a standard air pressure in a sand condition or desert or beach? So normally with the standard tire pressure, the tire's contact area is reduced, right? So that there is a high possibility of having some stuck wheels inside the sand, right? මේ වැලි තියෙන තැනක එහෙම නැත්නම් traction එක අඩු තැනක standard air pressure එකෙන් drive කරොත් අනිවාර්යෙන් ඇරෙනවා, right? Surely the tires will be stuck inside in the sand, so that if you see that your terrain is having some sand conditions for a beach or desert. So first you need to reduce the tire pressure, right? So once you reduce the tire pressure, what happens? So let's go back to the reduced tire pressure section. Yes, the contact area will be increased, right? Contact area will be increased with the lower inflation pressure, so that the pressure applying on this particular area will be reduced. So then there will be a less possibility of having stacking inside the sand, correct? මම කියන එක පැහැදිලිද? දැන් අපි ස්ටෑන්ඩඩ් එයාර් ප්‍රෙෂර් එකේ ගියොත් මේක තියෙන්නේ මෙන්න මේ වගේ ෂේප් එකක් ටයර් එකේ. ඔව් වැඩි එයාර් ප්‍රෙෂර් එකක් අනිවාර්යෙන් එරෙනවා. මෙන්න මේ ඒරියා එක අඩු නිසා grip වෙන්නෙත් නැහැ. අපි එතකොට කරන්න ඕනේ එයාර් ප්‍රෙෂර් එක සෑහෙන අඩු කරන්න. So, normally let's say we have 35 psi inside the tire, so we need to reduce up to let's say 20 to or 15 psi. So then we can easily drive with the beach or desert or sand conditions, right? So that's all regarding wheels, I think. So you have a practical on wheel balancing. So you can get more exposure on the balancing and the static and dynamic balancing special during the practical sessions. And yes, that's all for today actually. So any question regarding today's session, and especially for tires? Since you don't have any questions, then we can wind up the session for today. Actually, I was hoping to start the next chapter as well, the braking system, but I can see that the time is not sufficient for today. So, Sanuka, can we have another session on tomorrow or Wednesday? So, please inform me about any vacant session on this week. Then we can start the braking system. Then, right?
Okay, sir.
Okay, that's great. We can have better to have some additional session on this week. Since this is online, I think you all can join, right? Okay, then let me wind up the session for today. Thank you for joining.
Thank you, sir.